Hey guys, welcome to another video. I'm so excited about this one. Today, I'm going to be walking you through how I built a Spotify recommendation engine from scratch in Python. If you're not familiar with what I'm talking about, what that means, at the bottom of each playlist in Spotify, there's a section that says, here's some songs you think you should add. My goal for this video is seeing if I could use my own methodology to replicate that feature. Definitely tough, but I'm excited to show you the results. Came out a lot better than I expected. Before I do jump into the code and into the Jupyter Notebook, I want to highlight a couple things. In the description, there's a ton of useful information for you guys. One, the GitHub repo, so you can take this code and play with it yourself. Also, my blog, LinkedIn group, my LinkedIn itself, all stuff that I think would be super helpful for you. Definitely let me know what you think. And lastly, if you haven't already, please subscribe and let me know what you think about the channel itself. I think I'm just getting this off the ground, so your kind of support is absolutely invaluable. Now that I got that out of the way, let's hop into the code. All right, perfect. So now that we're in a Jupyter Notebook, I want us to take a step back and essentially talk about the methodology, the process I'm going to take, and talk about the limitations. The one piece of advice I always give to kind of junior data scientists is really get everything on paper, illustrate exactly how you want to go about doing things, because 9 times out of 10, it's going to save you time later on down the road. Less rework will be required. So yeah, I want to show you how I go about illustrating it, and hopefully it kind of helps you in the future. So kind of jumping in, there's pretty much a 5-step process of how I actually built this algorithm, built this model. Most of these are what you'd expect. I'm imagining step 4 is actually a little odd. It probably won't make the most sense, but for now, just assume it's a way that we can summarize a playlist in my Spotify and generate recommendations based off that summary. We're going to definitely hop into the methodology and how I actually go about doing that, but for now, that's should be enough to kind of get you on the same page. As far as details, the algorithm type that we're using, so we don't have any user engagement data naturally because I'm just kind of not working at Spotify. I'm working off of a Kaggle data set. So we are going to be working with a content-based recommendation system that is just leveraging the features and attributes about a song in particular. So because I don't have user engagement, I'm gonna have to go with that sort of algorithm, and you'll see the results are still pretty quite good using that approach. Limitations. So I'll show you really quickly. I'm working with this Kaggle dataset here. I'm including the link in the notebook so you can take a look yourself. But I wanted to use this because it makes it really easy for me to prototype. I can get things off the ground really quick. But I will mention that sure, there's 160,000 tracks here, but it's not 100% coverage with what may be in my playlist or your playlist, etc. So what you might see is maybe when I look at this data set, I might get maybe 30% or 60% of the actual tracks are in my playlist. Sure, it's not 100% coverage, but that's not that bad because at the end of the day, even if I'm using a subset of the tracks that are in a playlist, I'm still able to evaluate does the recommendation system works, which is what I really should be focusing on. So even though this is kind of a limitation, I don't think it's that big of an issue. So I'm still going to proceed. And lastly, there's only genre metadata provided. So there could be a wide variety of metadata that the actual Spotify team is using. In my case, I'm only using kind of genre descriptors, which you'll see is completely fine, but I do want to note that. And say if I was giving a presentation to executives, etc., this is the kind of details I would note so that everyone's on the same page and they know what to expect. Also, there's so many different steps and there's so many different things that we're going to go into in this video. You'll see in the description, there's timestamps for each of these sections. Please feel free to go ahead if you're really curious and wondering about a specific section that's there for you, just to make sure you can get to the section that you really care about. And also, I'm not going to go over the data preparation because it's going to take way too long. And I think if you just go through the code and go through all the comments that I provided there, I think you'll be able to understand exactly how I went about prepping the data. So with that, I'm going to jump straight into the feature engineering and show you how we built and structured attributes in a way that helps us start to generate recommendations. So let's get down there. All right, cool. So we're at the feature engineering section of the notebook. And as you kind of saw right there, I made sure everything is like really structured in the code so that you know exactly kind of what portion of the code is doing what. There's three main steps that we're going to take. One is going to be normalizing the float variables. If you look at this data set here, you'll see things like energy, instrumentalness, liveness, loudness. These are all kind of technical descriptors of any particular song. So you just notice of loudness and liveness, right? The magnitudes are so different. So I want to include them, but I want them to be in the same scale so that the model isn't skewed towards one attribute versus another. So that's why I'm gonna scale those features. Then one hot encoded, you might see this OHE. That's the acronym I use for one hot encoding. So if you ever see that, I hope that doesn't confuse you. If you ever see that, it means one hot encoding. So there's two features I want to encode. You'll notice there's release date and popularity. I don't want to naturally release date. I can't input as is. Popularity, I also don't want to input as is. I'd rather bucket it into like cohorts of popularity. So what I'm going to do is create one hot encoded features of the year and a bucketed version of popularity, which you'll see right here. So this piece of code, essentially what I did is rather than put each popularity increment kind of by itself into the algorithm, I created 5 increment buckets. I think for me, I think abstracting it a bit doesn't harm the model at all. I imagine like if I'm typically listening to music between 90 and 95 popularity, any recommendation within that range will probably be a good fit for me. So that's, I think that assumption and that logic in itself kind of makes sense in my eyes. So I'm going to go ahead and make sure I go ahead and do those buckets. I want to mention, right, this is a prototype. I think this bucketing system is something I definitely would want to taste or test as I go forward and maybe put this into production. I think when you build, you have to think about all these parameters that you may want to say A/B test. If you're not familiar with A/B testing, like running experiments to figure out what type of bucketing works well, right? And I'll mention later on, there's other parameters that you could potentially test. When you're prototyping, and whether you're prototyping for yourself or you're actually working in a large corporation, thinking about what can be parameterized that can be tested later on is really important for a data scientist. So those two features are going to be bucketed and created one hot encoded features. And then I'll show you, let's see, is that here? Great. So here's one example. Seems like the start and end of the data set didn't have what I needed to. But essentially, the one last feature that we're going to handle is this consolidated genre list. And this is really going to drive the algorithm. So using an approach called TF-IDF, and I'm going to show you exactly what that means and what that does. I'm going to take this text data, this text list, and create features based off of it. And like I mentioned, because if you see Chinese indie rock, if I can learn what type of these genres are in a specific playlist, I'll be able to probably generate pretty reasonable recommendations. So without further ado, here are some functions. You can go through it on your own time, but this function allows me to quickly encode any feature and give it new column names, etc. This is just kind of the nitty gritty, but I encourage you to take a look at your own time. So the TF-IDF overview. So there's so many resources online. I'll provide some as well, but essentially what I want you to take away from this overview is it automatically emphasizes, i.e., like provide weight to specific song genres based off of how often they appear. So if there's a like rock or if something generic like pop, if pop appears, I don't want that to have a very high weight or really influence the model as much just because it's so generic, right? But if it's something really specific like abstract classical, if that shows up, I want that to really influence kind of where the model goes or the direction of the model because it's so unique. And if I find that there's a playlist that is like 9 or 60% abstract classical, I want that to really matter because I think any other abstract classical song would be super good fit, right? So I'll show you later on. There's a thing called cosine similarity, which helps pair two together. But for now, just note that this really simple yet elegant kind of algorithm allows me to easily weight a specific metadata tags based on how often they appear. And that is so critical. And one thing I will mention, I think there's so many more complex approaches you could take to vectorize text. TF-IDF, I feel like I haven't gone wrong. I mean, this it's just so powerful. I've used it in production code in my own kind of workforce at Disney, which I think it's amazing, right? I think it's so simple, but really carries a lot of weight. So now that we're kind of on the same page for kind of what TF-IDF is, I had this feature which essentially takes that entire Spotify data frame and then creates one large feature set, which you see here, that I could then use to generate recommendations. So you see this genre pipe, right? This is kind of how I've structured and organized these types of features. And just look at kind of the granularity of a lot of these features: acid rock, acid trance, acousmatic, right? Now you probably get a feel for why I think this is going to be so informative and useful for this model. I think this level of granularity can allow me to learn so much about what types of songs are in a specific playlist. And it can't be understated how powerful that is. And it just gets me thinking, imagine if imagine what other type of metadata Spotify might have, right? They probably have tones, except like so much granularity there that I think could create even more robust model. But let me scroll to the right so you can see some of the other features here. This is, I hate this. Okay, cool. So you see the year column here. Let's go to the right. Yeah, you see all these like literally I don't even understand some of these. These are like probably very foreign. I'm not entirely sure which nation they're from. You see the tempo, liveness, these are all included. These are the popularity buckets that I mentioned, and then the year bucket. So everything is here. And what's beautiful about this is for this use case in this video, I'm showing you how I could generate recommendations based off of my playlist. But I could easily use this and say, oh, let me just, based off of one song, what's the most similar song? This data set can be used for that. So while for this video, I'm just showing you recommendations for playlists, you could definitely use this like data set for so many different kind of applications and kind of use cases within kind of Spotify and the movie space, right? Which is I think is really exciting. And I'm sure I'll probably build something else after I'm done with this, which like I said, is pretty cool. Okay, so now that you have a feel for kind of what's in our feature set, let's take a quick tangent and segue and talk about the Spotify API. Couple things to know. I think this code base is really simple and easy to use. Here are some like the two useful links that I use to kind of get this off the ground. Very simply, you put your ID secret here. Let me just show you the dashboard. So I'll quickly log in here. I was logged into Facebook, but you can log in however you'd like. This is essentially the dashboard here. You can see like I've been using it quite a bit in the past few weeks. This is the client ID that you pull, and I'm not going to show you the client secret, but you saw these two features here, or these two what's called variables here. That's kind of what I took directly from kind of this section right here. So this, I mean, it's pretty easy to use. For me, all I used was the client ID secret. I'm sure there's a ton here that you can use. I just haven't had to. Also, you could use the Spotify API directly, but these guys at Spotify built an amazing Python mask for the Spotify API, which I'm not going to go through this entire documentation, but I encourage you to check it out, right? Like let me just user, right? It's so simple, like current user follow playlist, right? Add a follower, right? It's just what people are following. There's just so much here, right? You can find like tracks, etc., right? It's unbelievably easy to use, and I encourage you to check this out. I feel like it would take you a day to get you off the ground and start extracting live data from Spotify. It's unbelievable. I can't kind of emphasize how great this is enough. So now like you'll have these two resources in my code, so definitely take a look in your own time. I'm not, like I said, I'm not going to go through this code just because it's really easy for you to pick up yourself. I have this function here that takes an input, which is what playlist I want to pull. So let me just show you real quick. Cool. So what I did here is essentially pulled all the playlists that are in my profile. So these are my Peloton soundtracks, chill, EDM. These are all kind of some of the playlists I put together over the years. I built this so that if I ever want to just pull the playlist ID, I could easily use this dictionary just by typing in the name, which I'm probably going to be more familiar with, right, rather than memorizing this. And that's kind of exactly what I did. So this, here it is again. So this kind of function takes EDM. So also, I want to preface, don't judge me on my music taste. This that's not the point of this video, but I am a big fan of electronic music, and that's going to be the example that I show you here. ID name. So what this allows me to do is pull input the name of the place I look for, the dictionary that I put together, and then that Spotify data frame that we've been kind of going to throughout this entire video. And what it outputs is essentially this data frame here. So now I have all of the songs in descending order based on the date. All the songs based on descending order based on the date, and kind of now ready to go. Now I have in tabular format the songs that are in my playlist. So kind of really getting close there. So now I have kind of all the information I need. Okay, cool. So at this point, I think you have an idea of how I kind of use the data, and what I did with the Spotify API essentially was to get this data frame that I'm going to then use to summarize and generate recommendations for. So playlist vector. So we talked about this before. It might have seemed confusing. So let's actually dive in and talk about what that means and how we actually go about doing it. This might seem like a lot, but let's break it down. It's actually really, really simple. Imagine this is my playlist, right? Song 1 through 8 is in my playlist. This whole section here is essentially all the attributes that you saw above, right? You saw all those genre columns, the song year, popularity, all the float values. That data set that I took you through like not too long ago is essentially what you see here. Added columns are what I'm going to call months behind. And the reason I have this, and the reason why you see this weight and months behind, what I want to do is intuitively apply a recency bias, or prioritize the songs that were added more recently versus the songs that were added a long time ago. And I think that should make sense, but the main reason behind that assumption is I've had playlists that I had for years, right? Multiple years. And I know that some of the songs that I added early on really don't reflect kind of my current taste, or my current, even what that playlist represents at this point. So to avoid that and kind of overcome that, I've added this essentially recency bias. So what happens is, taking months behind as an input, I can create a weight that I then use to reduce how much this row provides kind of an input into the model. And the math is quite simple. So for 2 months behind, the weight ends up being 0.75. 0.75 gets multiplied across this entire row, which after it gets aggregated, which you see here. So at the very end, we just add up all of the columns. We get this final playlist vector. And naturally, if this has a really low weight and this low weight is multiplied across this whole row, song 8 isn't going to play a huge factor. It's not going to really matter as much when we add up all of these rows, right? And I think you could get a feel for how that really simply but elegantly allows me to summarize all the playlists, or summarize all the songs in my playlist, while prioritizing songs that I added more recently. I hope that made sense. I think, like I said, you'll have this document. I think you'll be able to go through the code, and you'll actually be able to go through this slide in kind of more detail. But at the end of the day, it's really this 2 columns here that help kind of unlock that ability to add a recency bias. And then, like I mentioned, here's the code that kind of allows me to do that. This code essentially, or this function essentially does the logic that I've kind of illustrated here. So, okay, cool. So now I've created, so I'll show you really quickly the shape of this. As I kind of mentioned, it's one row here, which is exactly what I wanted. This playlist vector is one row, which corresponds to kind of what I have here. And you might be wondering, what is this other data frame here? That is essentially my feature set without those the songs that are in my playlist. Because if we're generating recommendations, don't want to generate the same songs, right? Or add the same songs as a recommendation. So I just remove those so that there's no duplications or any issues there. Okay, so now the fun part, actually generating recommendations. So this, it can only be done based off of cosine similarity. And if you're not familiar with it, again, there's so many resources. This is a pretty simple kind of algorithm, if you want to call it that, or tool. And it's a tool that has allowed me to really quickly kind of generate scores and recommendations. So let's take a look at this plot, right? So I know there's over 2,600 inputs that go into this model, but imagine these inputs are one arrow, right? And that's essentially what you see here. All these inputs are essentially a vector, right? So this vector points in some direction, and this is my playlist vectors. So this is the guy you see right here or right here. That playlist vector points in some direction, and each rows of my feature set would be considered a song vector, right? It's They're both vectors, they both have the same attributes, just one is representing a playlist, whereas one is representing a song. What cosine similarity does is takes the angle between those two vectors, right? Playlist vectors here, song vectors here, and that angle essentially corresponds to the similarity, or essentially how good of a recommendation that song would be. Now, this note just states the smaller the angle, the higher the song score. So, and I think that should be pretty intuitive, right? If a song vector and a playlist vector are kind of pointing in the same direction, that must mean it's a good fit. And because they're pointing in the same direction, this angle would be pretty small. So I think the logic makes sense, right? Like, smaller the angle, the more they're in the same direction, the better the recommendation. And that's essentially what I have here. So let's actually analyze the results. So here are the recommendations that we actually see in my Spotify account, right? And these are all very like electronic music. We see Forbidden Voices. I want you to remember this song, um, Galantis. We see this artist. Here are some other ones. These are all like pretty big name kind of festival type of electronic artists. And here's a visual of my recommendations, but let me actually show you the tabular formats. It's easier. Cool. So off the top of my head, I think the same quality of artists are here. See Calvin Harris, right? Like Galantis. I think that's very similar to what you see here. What else? Alesso, that's also a huge name in this space. Yeah, let's see. What else do I see here? Oh, there you go. So like, it's not as high up, but I do want to mention I'm not using the entire playlist because there were some gaps between what's in my playlist versus what's available in Kaggle dataset. So naturally the recommendations would be similar, but it is cool to see that in my top 40 recommendations, um, there's a commonality between what Spotify is recommending versus what I'm recommending, which I think is like a good substantiation of kind of what I've built here. And given that the model is still naive, it's nice to see that we're pretty close and definitely going in the right direction. Um, yeah, so I think, like I said, super exciting. I think there's definitely a lot in this video, but I recommend if you are interested and want to start building stuff like this on your own, rewatch this, break this up into small segments, right? And go through the code while you're watching this video. I think all of it will make a lot of sense. I didn't go through the nitty gritty. There's subtle things that maybe I skipped over, but I really want this video to be really an overview and give you the high level kind of flow and methodology that I've built into this notebook. And the nitty gritty, I think you could definitely kind of tackle on your end while you go through the code yourself. And in the description, you'll see my LinkedIn there. In the comments of this video, feel free to ask as many questions as you can, as detailed as you want. I'm there to provide as much kind of input and guidance as possible. So don't hesitate. Feel free to kind of reach out as much as possible. So that wraps up this video. I hope you found it interesting. I hope you learned a thing or two. I'm definitely going to keep putting out content like this, any other project that I work on. I guess with that, definitely like, subscribe, let me know what you think, and I'll see you guys in the next video. See ya.